use algebra to solve each equation, so we have some solving ones on our quiz this afternoon. Here we have 2 sine x equals 3 plus 2 cos x. Okay? The key thing is we notice this has the word solve in it. It doesn't have the word prove. Proving questions is where we draw the line and work on both sides separately. A solving question means that you can work on both sides. You can move things over to one side if you need to and solve it just like you've solved all the way along. The only thing different here is in A, we notice that we have sine and cosecant. So I'm going to write my cosecant as 1 over sine. Because one thing that we learned in last year was solving systems of equations where you have 2 variables is that you can't solve one equation if you have 2 different things in it. But if you can rewrite that equation with all the same variable or the same function in this case, then you're going to be able to solve it. So what did we just do? We used the substitution technique. We knew that cosecant is equal to 1 over sine, and so if we substitute that in, then we've got an equation that only has one thing to solve for. Now our equation only has sine. So now we use our equation skills from previous years. This will be 2 over sine x. And ask ourselves, if I had something similar from last year with just x's instead of functions, if I had that, that's a rational equation. How do you solve rational equations? You can get a common denominator all the way through. You can multiply to get rid of that common denominator. Okay, there's some strategies to use. One of the things that you're going to want to do is get rid of the fractions. So you can get rid of the fractions by first getting a common denominator and multiplying, or you can get rid of them by multiplying right away. Can you see my fraction is a sign? Okay? So what would I have to multiply both sides of the equation by to get rid of the sign on the bottom? I'd have to multiply both sides, this side by sine and this side by sine. When I distribute this on this side, can you see that I'll get 3 sine x plus, and here when I distribute, I'll just get 2, because that was our plan, to get rid of that fraction. And on the left-hand side, 2 sine x times sine will be sine squared. So off to the side here, when I wrote this, that was to trigger your strategies from grade 11 in solving rational equations. And the strategy that I wanted to trigger was getting rid of a fraction. If we can get rid of the fraction, then it'll change it to something else. Well, what did it change it to? What kind of equation is this one? A quadratic. So now we have to go back to our grade 11 strategies. How do you solve quadratic equations? You make one side equal to 0, then you have your quadratic formula, or factoring, or completing the square, depending on which technique you'd like to use. So if I move everything over to this side, 2 sine squared x minus 3 sine x minus 2 equals 0. Again, if you can factor, factoring is always the fastest strategy. So when I look at this one and I go to factor, the only way that I can get a 2 sine squared is a 2 sine x and a sine x. The way that I can get a 2 is with a 2 and a 1 or a 1 and a 2. So looking at this, you have to make a decision. Should it be 1 and 2 or 2 and 1? Which one, when I multiply it out, will give me a 3? Well, I'm going to need a 2 here and a 1 here. So my outside makes 4, my inside makes 1. So when I multiply that out, I could get a 3. How do I get a minus 3? I would need to have a minus 4 on the outside and a plus 1 on the inside. Every time I do a factoring like this, after I'm done, I do a quick check. Do my first ones give me 2 sine squared? Yes. Do my last ones give me a minus 2? Because I added the signs at the end. They do, because plus 1 times minus 2 is minus 2. Does my outside and inside, when they get combined, give me minus 3? Yes. So I now know that this is the correct factoring. So we can split it here and say either sine x is equal to negative a half or sine x is equal to 2. Is negative a half on our pie plate? Yeah. This one here? If I set it equal to 0, yeah, if I set this equal to 0, negative 2, this one here will give me this, will give me that negative 2. Okay. Then the outside, this will be minus 4 sine x, and this one will be plus 1 sine x, and the outside and the inside will combine to give me a minus 3. Okay? So that's how we go about looking at doing the check to see if it works out to what it was before. So, is a half on our pie plate? Yes. What family? Pi over 6 family. What quadrants are we going to put our pi over 6 family here for? Quadrant 3, so that'll be 7 pi over 6, and quadrant 4, that will be 11 pi over 6. What about sine x equals 2? How can we do that without our calculator? 2 is not on our pi plate. It's not possible because this would be 2 over 1. Can you have the opposite side over hypotenuse be 2 over 1? No. Sine and cos can't be bigger than 1, so that's why we know that side is not possible. Now, I solved this between 0 and 2 pi because that's what we normally often have to do, between 0 and 2 pi. I should go back and check because maybe the question wasn't in radians. Maybe the question was in degrees. Or maybe the domain wasn't from 0 to 2 pi. So one of the things you should always check in the end is what was the domain that they were asking. In this case, we were fortunate. It was between 0 and 2 pi. So we don't have to change our answers. But sometimes it might be from negative 2 pi to 0. So then you would have to go and further think about what would be coterminal with the answers that you got. Okay. So that one had a lot of things that it connected to, right? It connected to solving rational equations. It connected to solving quadratic equations. So you can see that the questions you get in grade 12 go back to stuff you've learned in previous years and require that you remember how to do those kind of things. And so they sort of, and we'll do the same thing. We'll review techniques that come up from previous years when those questions come up. But one of the main strategies that came out in part A is we can't solve an equation until we can write it with just one trig function. So now when we go to part B here, sine x equals cos x, I want you to think and I want you to be creative. How could I manipulate this so I write it with only one trig function? Where you could just look at and think of your unit circle. If you just looked at this one, thought of your unit circle, you might be able to say, I know that at pi over 4, they're both root 2 over 2. And I know at 5 pi over 4, they're both negative root 2 over 2. So this could be one you just look at and solve. The other thing I said is, could you write this as a single trig function? Well, if I divide both sides by cos, what does this become? and this becomes tan x. And so by dividing both sides by cos, I write it as tan x equals 1. That's on your pie plate. When is tan x equal to 1? Pi over 4. Quadrants 1 and quadrant 3, 5 pi over 4. Oh, same answer. So question number 10 is more practice with these solving ones.